I'm going to introduce a practical approach for the Monte Carlo value at risk. I'm going to use two softwares. So on a first stage, we'll be conducting it on the R console, and on the second stage, we'll be conducting it in Excel. So first, I generate my data using the rnorm function. And as you might know, value at risk is a quantile function. So this implies that there is 25% chance of losing a minimum of 0.6730931. Okay. And now I'm introducing the Black-Scholes pricing model. So in the Black-Scholes pricing model involving the Monte Carlo simulations, we need first of all to initialize the number of Monte Carlo simulations that we want. In this case, it's n given as 10 to the power of 6. I'm going to copy the whole thing and paste it here. So I'm using the S0 as 10 power 4. This is my capital value. I'm using mu, my risk-free rate, as 0.05. Sigma, being the volatility, is 0.35. And I'm using a time horizon of 1. So in the Black-Scholes pricing model, you have the volatility being associated to a constant factor. When in practice, it usually follows a stochastic process, which was widely discussed in the Heston model. But we are doing the Black-Scholes model, so we are initializing sigma to be a constant value. Now I generate my data. Not my data, but the standardized normal distribution that we use in the Black-Scholes pricing model. And here you have the Black-Scholes equation that I've written in, that I've coded in R, my ST. I'm going to initialize R as a vector in the vector form, where R is given as ST minus S0. And you have my Monte Carlo value at risk. I don't have alpha. Alright, I missed value of alpha. So I write my alpha, and you see what your value at risk is. So this is there is 5% chance of losing about 4,433.754. Alright, so now I'm going to repeat the thing to show you what happens. See that the value changes because because of the random generation of our norm. Let me do it again to show you how the value keeps changing. Alright, so this equation here is actually a closed form of my Monte Carlo value at risk. Instead of initializing my instead of randomly generating numbers, we can get it in a closed form, and this is the closed form. Alright, so you can see that all my minimum potential losses, 4433, 4431, 4442, is actually being closed to 0.4439. Nice. Now I'm going to show you the in Excel how it can be conducted, the value at risk for Monte Carlo for a 2-security portfolio. So first of all, I've set my portfolio value to be 1 million. I'm using 2 securities, which is Apple and GLD, which is a gold trust fund. Portfolio weights being 90% and 10% respectively. I'm using RF as 0.00%. Let's make it to 0.03%. Let's change it. I can even change it to 0.05%. I'm using this as sigma and my time to 21 days. So how do you actually conduct it? So first of all, I need to specify the number of Monte Carlo simulations that I want. So I want 5,000. So I'm going to go on the Fill Series button, go to Series, select Columns, and make a stop value of 5,000. I'm going to click OK. And now I want my seed value to be the Scholes pricing model. So it's going to be exponential. And I start writing inside my bracket. So first I'm going to have mu minus 0.5 multiplied by the sigma to the square multiplied by time. So bank usually deal with divide by 252. Okay, to get daily value at risk. Plus sigma multiplied by square root. I go inside the square root, which is time over number of days over 252 multiplied by the standardized Z, which is norm S inverse. So inside my norm S inverse, I'm going to place a random distribution. Alright, this is my seed value, and I need to copy the whole function everywhere. So what I'm going to do is I'm going to do it in the form of the data table. So I select the data table. I go to data table, I go to what if analysis data table, and I click on any empty cell in Excel. I click on OK, and here I have my simulated values. Now if you want to play with it a little bit, you go to formulas and you click calculate. Now you will see that the simulation changes, the values change. Fun to do. And now I'm going to calculate the percentage loss at 95% and 99% confidence interval respectively. So it's going to be percentile of this I have to scroll up 1 minus this. Let me just, okay, it's actually 1 minus before here. This is my percentage loss, and I'm going to fix this here because I don't want to scroll over again, and I'll just drag the function. Alright, so it's being respected, and now in terms of absolute value it's going to be 12% times this. I want to fix the B3, which is the portfolio value, and I just drag. So at 95% confidence interval, you're making a maximum loss of 119. Okay, let me interpret this for you. For minimum 5% chance of losing a minimum of 12%, which is 119,954, and at 99% confidence level there's 1% loss of losing a minimum of 16%, which is 163,681. So this ends here for the Monte Carlo value at risk simulation. I have covered it using R and Excel, and yeah, I hope it assists you in your financial studies.